Hello, welcome. Let's try to solve another Leetcode problem 725, split linked list in parts. So I don't want to read the descriptions, but let me just explain it. So definitely we need to return an array of the k parts. So the k parts actually it means the k split. So for example, we have the head of the linked list, and inside it's going to be a value of 1, 2, 3. So we want to split the linked list into k parts. Because there are only 3 numbers, but the k equal to 5, how can we split it into 5 parts? We cannot do that. Yeah, but we just prepare the first 3 parts. So inside it's going to be 1, 2, this is going to be 2, 3. And what left behind is we're going to prepare just an empty linked list, and this is going to be another empty linked list. Yeah. And we need to take care that the final return it is an array, it is a list, and inside it is optimal. It is optional. It can be a linked list node or it cannot be a linked list node. And we need to know that inside the final return it's gonna be the linked list. It's gonna be the node. It's not an array anymore. Yeah, we have to be careful about it because this is a list. Inside it is the list node. Now let's try to solve the problem. So what is your first intuition when you see such kind of problem? Because according to the description, let's just check the description. So the length of each part should be as equal as possible. So the idea is that no 2 parts should have a size differing by more than 1. So at most it's going to be 1, otherwise it's going to be equal. So this may lead to some parts being null. Yeah, so for example, some parts being null. And for the second example, let's check that. So the first one can always be longer. So for example, the first part, the length is going to be 4. And then as we cannot put a 4 because the difference of each part is going to be at most 1. And the further one is going to be longer. So this is going to be 4. And the second part of the length is going to be 3. And the third part of the length is going to be 3. Yeah. So the parts should be in the order of occurrences in the input list, and the parts occurring earlier should always have a size greater than or equal to parts occurring later. So this is what's the meaning about the description. So if we understand about here, normally we have a value of k. We need to split it into k parts. So we need to know the total number of the node. So this is going to be easy. We just need to loop through the head, and we can count how many of them. Yeah. Now, if we know how many of them, so for example, in this example, how many nodes? It's going to be 10. And how can we split it? Definitely it's going to be 4, 3, 3. But how can we get this kind of a 4, 3, 3? We can use a diff mod. Definitely the modular works. So we're going to use 10 divided by 3 and 10 modular 3. What's going to be the final result? So 10 divided by 3, it is 3. So 10 modular 3, it is 1. Yeah. So this means for each part, it's going to have a length of 3. But we have a modular of 1. So this means for the first part, we need to plus an extra 1. It's going to be 4. And the other part, the length is going to be 3. So this is the idea. So in mathematics, we just need to use a diff mod and to get the divisors and to get the mod. After that, we can just put it inside the final result. And this is an idea by using mathematics. Another one is if we already know what is inside. So for example, we're gonna prepare a count array. So inside we're gonna prepare the length. In this example, it's gonna be 4, 3, and 3. Now, we're going to check each of the numbers. So for example, for the first one, it's going to be a 4. We just need to loop through the linked list again, and we just need to check 4 nodes. So after 4 nodes, it's going to be ported to 5. And from here, for the first node, we need to put it inside our final array. And then if we find a head from here, we just need to put it inside, append it inside. But how should we know after we go through like 1, 2, 3, and 4, how should we let the 4 pointed to a noun? Yeah, because definitely this 4 gonna point it to noun. Otherwise, it's gonna be like 1, 2, 3, 4 until to 10. But our final result is gonna be 1, 2, 3, 4. This means for this 4, it's gonna be pointed to noun. Yeah, this is also easy. So it is just before we are checking this 5. We need to record a previous value, so this is going to be a previous value. Yeah, so for this previous value, it's going to be ported to none, and then we just directly get the answer. If you have a global understanding about the problem, basically we can start solving it. Yeah, so for me, I'm going to prepare a pointer p. It's going to be ported to the head because I'm going to use the head to loop through the linked list. So I'm going to prepare, yeah, let me use a count maybe. So the count is going to be equal to 0, so I'm going to count it. Yeah, so count is going to plus equal to 1, and head is going to be equal to head.next. So in this way, I have a count of how many of the nodes in my linked list, and then I'm going to prepare a DM. It means the div mod. I'm going to use the div mod to get the divisor and mod. So the div mod is going to be the count with the value k. Yeah. So let me just return an empty array, and let's check what is this d and k, because we're going to use the formula to get the final count array. So currently I'm going to give a 0. I'm going to give an empty array, but let's just check what is the div mod d and m, because this is really important for us to solving the problem. Yeah, so for the first example, the div mod is 0, 3, it is okay. And for the second example, the div mod is 3 and 1, this is also okay. And yeah, I will not explain the third example because it doesn't matter. It is just an empty array. If it is empty array, so the div mod is going to be 0 and 0. Yeah. Now let's just use this div mod to get a counter array. So this counter array inside will be the length of each part, because we're going to use the length of each part later. Yeah, but how can we get that? So the first part is going to always be longer. So it's going to be d plus 1 times how many of them. Yeah, so for example, for the first part, the d equal to 0, so 0 plus 1. Yeah, let me just go here. So the d equal to 0, so 0 plus 1, it is 1. So 1 should times the mod, because this is going to be longer. Yeah, and we're going to plus the left part, it's going to be d times what? D times k minus m. Yeah, so this is the formula to check how many of them. Yeah, because for the first part, it's going to be always more than 1, so it's going to be d plus 1, and how many of them it's going to be m, and what left behind is k minus m. Now let's just check what is the count array, because this is useful to solve the following problem. Yeah, let's just check the count array. So this is 1 1 1 0 0. It is okay because it is the length of each part. And for the second one, it is 4 3 3. It is okay. And for this example, because the k equal to 3, so for each part the length is going to be 0 0 and 0. Yeah. Now we're going to use this kind of a count to solve the problem. Yeah. So let me now just delete the grid. But how can we use the count to solve it? So we're going to prepare a C. It's going to be the count of each part. So for C, inside count, and for I in range, we're going to use in range C. So it's going to be the length of each part. Yeah. As we already have this pointer P, so P is going to be ported to the head. So what are we going to do? So for each part, first of all, we want to put it inside the, let me use a result maybe. So the result is going to be an empty array. So I want to put the head inside the result. Yeah. So the result is going to append which value? It's going to be the P. Yeah. And for here, for each part, I'm going to loop through the P. So P is going to equal to P dot next. Yeah. But this is not yet finished, but at least we did something. Let's just check what happens for the result array. Yeah, you know it didn't work, but at least it works for some cases. So for the first example, we know it is 1, 2, 3, 2 and 3, but we should have only 1. Why we have 2 and 3? Because we didn't control it. Yeah, actually for our function, you know, for each part, because the C equal to 1, so we just get a 1. Yeah, we put it inside, and this one, and we're gonna go to the next, we put it inside. But we didn't let this one while, let me use another color. but while the next pointer go to the node 2, for the previous pointer, it didn't go to a node of none. We needed to let it point it to none, but it didn't do that. So we needed to control that. Otherwise, yeah, it is just like the wrong answer. It's going to be 1 pointed to 2, 2 pointed to 3. Yeah, actually it is not like that. So for us, we just needed to let this 1 pointed to none. And this is going to also be easy. Why? Because we can use a previous pointer. Before p go to the next, we're going to record a previous pointer. It's going to be equal to p. Yeah. So this means finally, after each of the for loop, after this for loop, so while p go to p equal to p next, p gonna be pointed to 2, but the previous node gonna be pointed to none. So the prev dot next gonna equal to none. Yeah. So in this way, actually, it works for some cases, but not all of them. Let's just have a check. Yeah, it didn't work for some testing cases, but let me just delete this case 3. Let me test other cases. As you can see, at least it works for some cases, like case 1 and case 2. Yeah, actually it works. But now let me just submit it. What is going to happen? Yeah, this means we didn't consider the empty case. So what if the head is empty? What are we going to do? Yeah. So this means if the head is empty, the C gonna be 0 for each part. If C is 0, definitely we don't have the previous pointer. Yeah. So if we don't have a previous pointer, how can we let the previous pointer pointed to the next? That means it is not possible. So we have to check if there's a value of C. So we're gonna let the prev dot next gonna equal to none. Otherwise, we will not check the prev dot next. We directly put a p inside. Maybe p is just equal to none. Now let me just submit it. Now as you can see, the third case also works, and let me submit it. Now you can see it passed all testing cases, and it's pretty fast. So this is why I'm gonna explain this kind of problem, because I pretty like this problem, even though there's no reading. But this is a good problem. Yeah. First of all, we're gonna use this kind of a mathematical formula. Basically, this is not a hard formula, but this formula is going to be really interesting. We're going to use the diff mod. You know, for a lot of times, especially for the mathematical problem, we would like to use the diff mod. And this is why, for the diff mod, it's just so easy to solve such kind of problem. We just prepare a count array. We're going to use the diff mod. And after that, this is going to be another interesting thing. We have to use a previous pointer. And we need to know from where we need to record this previous pointer. It is just before p.next, and we need to check the value of C. If the counter, the length equal to 0, we don't need to record the prev.next. It is okay. Yeah, I think you can write as many ways as you like, but definitely you're gonna use this kind of a formula. This is a must thing we need to know. I think that's all for it. Thank you for watching. See you next time.